Algebra 2 friends. We're back. This is a very vocab heavy lesson, so there's a lot of terms and definitions that we're going to get down today. And we're going to talk about functions, domain, and range is the basic three ideas that we're going to talk about. But first, let's talk about the idea of, we're going to see algebraic equations. They're going to be in function notation a lot from here on out in Algebra 2. And anything that you can graph is considered a relation. So even a single ordered pair would be considered a relation. So when we write something in function notation, they have this weird, they have this weird notation over here, and we read this as f of x. It's a function with respect to x. You can use any letter you want, you can use any variable you want, but the idea is whatever my function is, whatever's in parentheses is what I'm using as my input variable. So if my function f of x is 3x plus 4, and I can use that function to find any answer that they ask me from there on. So f of 5, they want you to take 5 and put it into the function and get an output value. So the input value for f of 5 is 5. That's what they want you to put into the function. And then the output value is, we haven't calculated it yet. So if we take our function, which is this guy, 3 times x plus 4, and we put 5 inside of that, so 3 times 5 plus 4. All right, mental math. That's 15 plus 4, so our output value is 19. So I put in a 5, I get out a 19. A function is like a math machine, if you want to think of it that way. So here's a whole bunch of vocabulary for you. A relation is any set of ordered pairs. So for us, if we can graph it on what's called the Cartesian coordinate plane, it's a relation. Domain, there's a really fancy definition in our textbooks. It's like all values x for which the function exists. I'm just going to say all the x values. That's the simplified definition. The range would be all the y values. And then how do we know if it's a function or not? And that's going to be a big question for today. So a relation is a function if and only if every x value is paired with only one y value. So of course the formal definition is a little fancier. It says something like every input value has exactly one unique output value or something to that effect. The idea is every x can only have one y that it's paired with. We'll see an algebraic representation of that and also a graphical representation. So first, I give you this relation. So just to kind of connect our vocab here. This here, right now we can call it a relation, set of xy ordered pairs. And on the Cartesian coordinate plane, remember x values and y values, you can plot them like a game of Battleship on the coordinate plane. So if I plot the ordered pair 2, 4, that would be at 2, 4, and then negative 1, 3, and then we got 2, 6, and then we have 0, 2. Now there is no connection. This is not a continuous graph in any way. You don't draw lines in between them. It's just those 4 ordered pairs. That is the relation that they wanted me to graph. So this is what it looks like. And the next question is it a function? So the definition of is it a function said every x value has only one y value. So here's the problem I'm running into. This guy right here. These 2 ordered pairs. I'm going to say no, it's not a function. And the reason why is because, I don't know why I put a dash there. Oops. X equals 2 has 2 different y values or output values. So x equals 2, it gave you a 4 on one example of the ordered pairs, and then later on it gave you a 6 for the same x value. That's why it's not a function. All right, also by definition, the domain is all of your x values. So what we're going to do here is, because we have a listing in our relation, I'm just going to list out all my x values. And if you want to get really fancy, you can use what's called set brackets. They're not parentheses, they're not brackets, there's those weird squiggly things. So I'm just going to list out my x values. It's proper to put them in like numeracy order, increasing order. But if you don't, it's okay. And the other thing is because 2 shows up twice, don't write it twice. It's a listing of every x that shows up. So list it once. Our range remembers all your y values. Set. It kind of looks like set brackets. Again, in numerical order would be best. So 2 and 3 and 4 and 6. So that's one example of a relation that didn't happen to be a function because there was more than one y value with a single x value. This next example of a relation, so again, this is a relation. We're going to graph each of these xy ordered pairs. So 3, 4, and then -3, 3, and then 2, 4, and then 0, 5. Again, we don't connect these, we're just drawing those ordered pairs where they are located. And the next question says, is this a function? And surprisingly to some of you out there, you're probably thinking, no, it's not a function because something weird happened. But by the definition of functions, this is a yes, this is a function. Because, oops, every x value has only one y value. So this is a little confusing to kids at first because they're looking at this one and they're thinking there's a problem right here. They're wondering what's going on there. Well, that was a case where that wasn't an x value repeating and pairing up with 2 different numbers. That was a y value that was repeating. This is okay in function land. All right, the idea is only an x can be paired once. It doesn't say anything about y's. And we're going to learn another way to determine whether this is a function in a minute, and I think it'll make more sense. So again, by definition, the domain is all of your x values, getting fancy by writing it in set notation. Brackets are not looking good. All right, -3, 0, 2, and 3. Whew. Hope those get better before the school year starts. And then the y values for your range would be, again, don't write the 4 more than once. That's silly. All right, 3, 4, 5. It's ugly. All right, moving along here. This is what I was referring to earlier. Oops. So we have something called the vertical line test. If you have a visual representation of your relation, or you can visualize it perhaps, it's very easy and simple to determine whether or not it's a function if it passes what's called the vertical line test. And the idea is, if you draw a bunch of vertical lines through your graph, each vertical line can only touch one point or one part, can't touch twice. So a good example of kids graphing things for me, I'm going to graph a few here. When I'm in class, you guys give me some examples, and some kids like draw a line on their paper, right? Like a normal, like one of these. So if I were to perform what's called the vertical line test, I would draw a whole bunch of vertical lines through this, and this guy passes the vertical line test. I don't know why I wrote that all together. So the idea is, yes, this is a function. And then lazy teacher, I abbreviate function FCN. That's accepted in the math community, so you guys can go ahead and do that as well. And then usually the next thing kids bring up is something that they are remembering from Algebra 1, something called a parabola. And then if we perform the vertical line test on this guy, again, yes, this passes the vertical line test. So yes, this is also a function. So then come up with an example of something that doesn't pass the vertical line test. Usually I get this from kids. Maybe that's what you were thinking as well. There is such a thing as a sideways or a horizontal parabola. When you move on to pre-calc, you'll learn about this. And boom, there's not a very vertical line, huh? But the idea is there's a whole bunch of vertical lines that I could draw that shows an epic fail of the vertical line test. So because this fails the vertical line test, no, this is not a function. Okay, so if we go back to those previous examples we had, this guy right here, which we determined was no, it's not a function, right here, it would fail the vertical line test. So that would be a visual way of us saying, it's not a function. This one, however, if you perform the vertical line test, so you might draw one here, and you might draw one here, and you might draw one here, and here. All of those vertical lines were only intersecting at one point. They weren't hitting more than one point at a time. So this guy passes the vertical line test. Alrighty. Kind of weird, lots of vocab. I know, it's strange. So now let's talk about what if we have a continuous function, or a relation, I should say. So how do you write domain and range if it's continuous, meaning everything's connected? It's not just a listing of ordered pairs this time. Well, we're going to have to write them as intervals, because if I say give me every single x value that a line hits, you can't, because it goes on forever and ever and ever. So let's look at this example. We have, now notice there's no arrows here. It starts and stops various places. I want you to give me a listing of your domain, which is all of your x values. And there's a lot. There's a lot in between here because it's continuous. So the first thing I'd like you to do on your notes, because I think this will kind of help us as we move along in math. This is a really big concept for Algebra 2. Domain reads like this. From left to right, okay, like this. And for some kids, it helps them if they kind of draw some arrows going like this. So the domain is what's in between those two arrows. The confusing part though, I don't know why, because this is how most of us read books, right? You read it from left to right. It has to go in least to greatest order. So just like the intervals that we did on our compound inequalities, they're back. We got to do them here as well. So your domain starts at -6, and it has a filled in point, like a solid point, so we're going to use a bracket. And then it hits every single x value, and then it stops right here at 6. All right, now for the fun part, range. Range reads, now this is confusing, low to high. So the lowest y value to the highest y value. So on your notes, I got to write in all capitals because that's the only way I can write sideways. You guys can just turn your paper, but I can't do that. Range reads from the lowest y value up to the highest y value. So again, some kids like to put arrows like this. So it's whatever's in between there, but it has to read low to high. So be careful. The lowest y value that this guy starts at is down here at -3, and there is a point there. And then it goes up, comes back down, but the point is they want to know the interval for which it goes through. So it stops, it doesn't go any higher than 4. Again with a bracket. And then is it a function? Yes. And then it wants me to explain. Well, what I could do now is I could draw, because I have a picture here, I could draw a bunch of little vertical pieces there. And I could say, yes, it passes, and you can abbreviate VLT for vertical line test. Now, word of warning on a test or homework. If you tell me something is a function because it passes the vertical line test, then you better have a picture of it, and you better show me the vertical line test, because if I just am told, yes, function passes vertical line test, and you don't have any graphical proof of that, I'm not going to count you correct. All right, domain. Again, remember, domain reads from left to right. It's all of your x values. Range, however, reads from low to high. Ugh. All right. That was supposed to be straight. Low to high, and it's all your y values. So for my domain, I know this one's not exact, but it looks to me like it's about at -4. I'm just going to estimate it at -4. And then it goes as far to the right as 8. My range, let's see here. And we probably could argue that this is not dead on, right? That looks like a little lower than -4, so just for argument's sake, how about I say like -4.2? Whatever. And then it goes up to a little above 1, so maybe for symmetry, I'll go 1.2. I don't really care if you're a little off by that, guys. No, I'm not saying I'm right. I'm probably way off. All right, now let's perform the vertical line test. Fail right there. There's a whole bunch of places where it fails, but there's just one example of it failing the vertical line test. So no, not a function. It fails the vertical line test. All right. Oh, that's a weird guy. Looks like a horizontal parabola, but it's going a weird way. So same idea. Domain is from left to right. Range is from low to high. Now this time what I notice is we have some arrows on this picture. And pictures can be very deceptive. So whenever there's arrows, what I like to do is like really exaggerate them and like extend the graph. I know I don't graph very well, but pretend. Like really make it go off the graph. So that will not allow me to be tricked by the picture. Because now that I see that, I realize the domain over on the left side, like it never ends. It just keeps going and going and going. So when I ask you, where does your domain start? Like how far to the left is it going? The answer is like forever to the left, which if you think about infinities, that's negative, right? So this starts parenthesis at negative infinity. And then it ends right there at, let's call it 3. Now, because there is an ordered pair, because you're graphing something, let's use a bracket on the 3. That's a little confusing. I know, we're going to practice these a lot. Range. How low does it go? And if you think about this arrow, it goes down forever. And then how high does it go? Well, think about that arrow. It goes up forever. So I wouldn't be able to like cap off my range anywhere. So my range goes from negative infinity to positive infinity. It has to be in that order. Domain and range always go, any interval goes from least to greatest. So either left to right or low to high. And then is this a function? You can draw a bunch of examples of why it's not a function, but there's one right there. You're going to say no. It fails the vertical line test. Because I have a picture and I can show it. Perfect. All right, one more. Here we go. Again, we got those arrows. That's a little stinky. So I'm going to go ahead and exaggerate them because it continues on and on and on. I don't want to be deceived. The domain, remember, is from left to right. So I might ask you like, hey, where does it start? And the answer is like, it goes way over there. And then to the right, where does it end? Like, it doesn't. So the domain for this particular function, oops, it's a function, goes from negative infinity to positive infinity. Notice I'm using parentheses on all infinities. The range, this one tricks kids, so be careful. I think everyone has the right intention when they give me the range. They just get a little confused. The range is low y value up to the highest y value. Think about what y value is right there. That is a y value of 0. So the range starts at a height of 0, and then it goes up, up, up forever to infinity. And then I already spilled the beans here. It is a function because you're going to show me this. You're going to be, oh. Helps if you can actually draw a vertical line, and you're going to say, yes, it's a function because it passes the vertical line test. Lots of vocab, right? Lots of vocab. Domain and range, huge concept for us in Algebra 2. We're going to be hitting domain and range on every single function we learn about from here on out. So make sure you're getting really comfortable with the intervals. And of course, now it's time to practice, practice, practice. All right, good luck, everybody.